Welcome to Study Loop.
In this problem, we are given the volume and density of methanol. We're not given the molar mass, but you can find that using your calculator in your periodic table. So this is one component, and what we're doing is we're mixing these 22.5 milliliters of methanol with 98.7 milliliters of acetonitrile. And again, for acetonitrile, you're given the density. You can find the molar mass with your periodic table. And we're going to use this information to calculate a number of different concentrations for this mixture. So the first one that we're asked to find is the mole fraction of methanol. Recall that mole fraction has this formula where we calculate the number of moles of a given component, in this case methanol, and we divide that by the total moles present in the solution. So that will give us the fraction of the solution that is pertinent only to methanol. So to start with, we're going to use the density and volume of methanol. When we multiply these two together, 22.5 milliliters by the density 0.791 grams, for every 1 milliliter, we find the mass of methanol present in this solution. So that's 17.8 grams of methanol. Okay, that's still not what we need. What we actually need is the number of moles. So we're going to take an extra step and convert number of grams of methanol to moles of methanol using the molar mass that we can find from the periodic table. So the 17.8 grams can be converted into moles by dividing by the molar mass, which is 32.04 grams for every 1 mole. What that will give us is 0.555 moles. And again, this is moles of methanol. It's important that we label these so that we can keep track of what all these numbers belong to, both with units and with the substance. Okay, so that's what we know about methanol. Then for acetonitrile, we're going to repeat the same process because we need the moles of methanol as well. Sorry, not methanol, acetonitrile. So we're going to use I want it in green, 98.7 milliliters of acetonitrile multiplied by the density. To find that we have 77.6 grams of acetonitrile. Again, I'm going to set that information aside, and we're going to use it to calculate the number of moles of acetonitrile. So again, starting with now the mass and dividing by the molar mass, which is 41.05 grams for every 1 mole. The number of moles of acetonitrile is 1.89. And again, that's moles of acetonitrile. Okay, how does this information help us? Well, like we said, mole fraction is, oh my gosh, sorry, this is harder than it looks. The mole fraction is given by the moles of the component. So that's the moles of methanol. So we've got moles of methanol, 0.555 moles, divided by the total number of moles. So the two components of the mixture are methanol and acetonitrile, so 0.555 moles, divided by the sum of the two, will give us the mole fraction. So put that into your calculator, and you find that the mole fraction of methanol is equal to 0.227. Now, this is a unitless number. Notice that the units of moles over moles cancel. Fractions are unitless, so having no units is what makes sense here. This is the mole fraction of methanol. You might see it given as capital X CH3OH. That big X represents mole fraction. Now in part B, again, same information. Now we're being asked to find the molality. Molality has the formula moles of solute divided by kilograms of solvent. So notice that we already have some of this information. We have from earlier, the solute in this case is methanol because it is present in a smaller quantity. So this over here is my solute, and the component that's present in the greater quantity is the solvent. I already have moles of solute. I found that earlier. It was 0.555 moles of methanol. For solvent, we need kilograms. In part A, we found grams of solvent. We found 77.6 grams. 77.6 grams of acetonitrile. Recall that there is, in 1 kilogram, 1,000 grams. So 77.6 grams of acetonitrile is equal to 0.0776 kilograms. Okay, this is the information we're going to use to calculate the molality. This is a side note. So we're going to write 0.555 moles divided by 0.0776 kilograms. That gives us 7.16. And again, the units of moles over kilograms can also be abbreviated as M, which stands for molal. So this is 7.16 molal methanol. Finally, in part C, same information. This time we're asked to find the molarity. Molarity has the equation moles of solute over liters of solution. I already have moles of solute. We found that earlier. It's 0.555 moles. Again, that's moles of methanol. Liters of solution. The question says that we can assume that the volumes are additive. What that means is that when I mix the methanol with the 22 milliliters of methanol with the 98.7 milliliters of acetonitrile, these guys are going to add up. So 22.5 milliliters plus 98.7 milliliters, that's the total volume, is equal to 121.2. Recall that we need liters, not milliliters. And so for that reason, we're going to divide by 1,000 because there's 1,000 milliliters in 1 liter, and find that this is 1212 liters of solution. And so we're going to divide these two quantities. First, the 0.555 moles divided by 0.1212 liters. That will give us a molarity of 4.58. Now, moles over liters is abbreviated with a capital M. Molality had a lowercase m. Molarity here has an uppercase m. That stands for 4.58 molar, and this is 4.58 molar methanol is the concentration.